So today we will be learning how to use rigid bodies to move in Unity. Some timestamps of the video will appear on screen right now. So first let's talk about what are rigid bodies. Rigid bodies are the physics engine in Unity. They control all interactions with physics. You can see it over here. And they are extremely useful. Today we'll be using two functions, .Addforce and velocity. Velocity, as the name says, controls the object's velocity, and Addforce applies a force to the object. Now, why should we use rigid bodies? Rigid bodies allow for extremely smooth movement and work great with spheres. They are also very easy to program NBC movement so that you don't have to code a whole separate script and controller for them. So this is what we will be creating today. I've made a simple script where we will adjust the speed of the object. We can turn on and off inertia, and we can increase and decrease the speed. So let's get to the tutorial. So now let's actually program the rigid body movement. So first, right-click, create new 3D object, sphere, and we have a very simple sphere on our plane. Now, if you have a material for the sphere, you can just simply drag it on so that you have a color on it. This should work with most objects, however, I think that sphere looks the best. Now, because we will be using a rigid body, we want to add a rigid body. So just type in rigid body, and you can add it. We do not need to alter any of these settings for now. Next, we need to create a script that will control our rigid body. So we can call this movement. Now as we can see, the movement script is here, it's compiling, and it's now here. So open that up in Visual Studio. Sometimes it will kick you out of your project, so you may need to reload the project like this. There we go. We see movement. Now we don't need the comments that are here. Now we will be accessing this rigid body. Now we need to access it within the script. There are two different ways to do that. We can either do public rigid body Rb or private rigid body Rb. Now with public, the variable will appear underneath the script in the editor, and you can drag on your object into there. Now for performance, this is not recommended because this will actually slow down your game if you have so many declarations like this. However, with private, what you can do is you can go and say rb2 dot is equal to transform, so this game object dot get component. We're getting the component from this object, and we want to get the rigid body component. So this is the way we will be using for this tutorial. Now, we will be using two functions, rigid body dot add force and rigid body dot velocity. Depending on what type of game you are making, these can be used both in different ways, but we will start off by using Rb.Addforce. So I'm just going to create a separate void. You do not need to do this, but this is just to organize my code. We're going to call it Rigidbody.Addforce for the first method that we will be using today. Now we want to call this an update, so Rb.Addforce. So we call the void. Now let's just try adding a force to our rigid body. So rigidbody.addforce, and a vector3 will always go into the rb2.addforce. So we want, let's just put in 1, 0, and 0. This will move it positive on the x-axis. Now as you can see, when we start our game, the sphere just moves left and then goes down for infinity. So let's quickly just create a simple function to make it so the sphere returns to the surface. So if transform.position.y is less than 0, then we want to do transform.position be equal to new vector 3 0. This will reset the position every time. Now, while we are moving, you can see that whenever we fall off the edge and that we come back to the beginning, the sphere never stops moving. It just keeps on going into infinity, going faster and faster. Now, one way to stop this is by setting Rb.velocity to 0. And that is the way we will be using in this tutorial. Now this will set our velocity to 0 every time we run this function. We only want to run this function when we are not adding force. So we can do that very simply. So we can put in input dot get key code dot w. So we're going, well, this is A actually because we are moving. No, we are moving this way. D moves right, so we know this is right, so we're going to put Rb.Addforce into here. Now, whenever we click the D button on our keyboard, we will automatically move in that direction, and if we are not, then we can easily just put this here. So now let's test. When we move and we stop. Now we move and then we stop. That works. So now let's put in all the rest of the key codes for it. So it's extremely simple. All we really did was we told the program to check, are we clicking D? And if we're not clicking D, check if we're clicking A, and then check if we're clicking W, and check if we're clicking S. Now this works as you're able to move in all 4 directions, as shown. We can click W, D, S, and A, and we can move. However, if we try clicking W and A to move diagonally, we're going to end up moving only left. The reason is because A is a higher priority than W, because it is higher in the order. Now, one solution to this is that you can do else statements. You can remove the else statements and do if a bunch of times. However, then what's going to happen is if this Rb.Velocity is going to happen only when S isn't clicked, which means you cannot move with W, A, or D. So to solve this, let's create a private bool called isMoving. Now, if isMoving, so we put an exclamation mark so we know we're not moving. We want to stop moving. Now we want to set isMoving to true in all of these statements. There we go. And at the top we want to set isMoving to false. Now this will mean that whenever this function is run, which is every frame, it will automatically set is moving to false, but if a key is pressed, because these are in this order, is moving will be true. However, if it passes over all this code and is moving is still false, which means that no keys were pressed, is moving will be set to false, which will cause this to happen. Let's try that. As you can see, we can even click 2 at once, and we're moving diagonally. Perfect. So this is a very simple way to move. If you would like, you can just turn off the velocity check, which will make it so that when you were to click, they speed up and slow down, and the ball gets the rolling feel you normally get. So if we move the game down here, you can see the ball is actually rotating. Now if we increase the speed, which would mean these ones, so say to 2, we can test that. Now it's extremely annoying to have to go into your script and change all 4 variables every single time you would like to change it. So an easy way to fix this is by creating a public float speed, which means we can now edit the speed in the inspector. Now we want to multiply all these values by speed, so we can make it so our speed controls how fast we move. Now, let's test that. Let's say we make our speed 5. You can see our sphere moves pretty quickly. I like this. Now, let us try to make a new version. We will be using Rb.Velocity, which is a very different way. I mostly use this one for shooting projectiles in my games, as it provides a constant speed instead of a changing speed, and also has a lot less bugs and things that can happen like collisions. It has a very constant, I'm moving this way speed. So we will try that. So now we will program the Rb.Velocity method. Now Rb.Velocity works best with cubes and other objects do not roll around, and that is because when an object is rolling, like the velocity of the sphere, it starts pointing downwards, which messes up the velocity and causes it to attempt to run into the ground, and we don't want that. So let's just quickly create a cube, color it, we disable the sphere, and let's put our movement script here. We can set our speed to around 10, and we can go into our Visual Studio. Now in Visual Studio, under Update, I've already created a function called Rb.Velocity, and I've commented out Rb.Addforce, so it's going to be a different one. Now, we want to do the same checking that we do over here, exact same script. However, instead of Rb.Addforce, we want to do something slightly more complicated. Now, we want to set the velocity of Rb2, transform.forward, multiplied by our speed value. Now this will mean the direction that whatever we are facing in, multiplied by our speed, will be the direction we move. So we set this to D, so now let's try using that key. We of course need to add a rigid body to this object. And as you can see, we can move. Now as you can see, it's being very weird and it is rotating around and spinning. Now the reason for that is that this object still uses gravity. Now because it uses gravity, it's being pushed this way, and because of the cube's edges, it will then start to rotate. And then that causes our transform.forward to get messed up and has a similar problem with the sphere. So what we want to do is turn off gravity. And as you can see, we can move straight, very smoothly. So let's copy this code to all of these. Now, if we're moving forward, we want forward to be W. Now we want negative forward, which is backwards, to be S. A we want to be left, so transform.left. As you can see, that doesn't exist, so we do negative transform.right. Right and forward are the only variables it gives. Then we change D to transform.right. As you can see, we can move in all directions extremely smoothly. So those are two types of rigid body movements, the ones we showed in this video. You can join our Discord. You can ask any questions for there. Just ping me or any of my team, and you can ask any questions about anything you have. Make sure you check out our game. We're working very hard on it, and we will come up with another update very soon. We just made this tutorial on the side. These are just two very simple ways to move with the rigid body. I remember using these when I first started. In the next episode of this series, we will be looking at moving using transform.translate. And we will be using transform.position is equal to vector3.lerp and vector3.slurp, which are slightly more complicated than this method, but this is a very small stepping stone to click to move, which is a little bit more advanced of a movement style. Thank you for listening to this video. If you have any questions, check out our Discord. It'll be in the description. I'll see you in the next tutorial.